1.119 on the board. A locomotive of mass m starts moving so that its velocity varies according to the law v equals a root s, where a is a constant and s is the distance covered. Find the total work performed by all the forces which are acting on the locomotive during the first t seconds after the beginning of motion. Okay. So it's given v equals a root s, and we have to find out the work done by all the forces in the first t seconds. Okay, and also the mass is given as m. When we have to find out the work done, we can use the work energy theorem. Okay, so work energy theorem says work done by all forces is equal to the change in kinetic energy. Okay. Now, this is important to realize this is work done by all forces, and that's exactly what this question asks. So all we are looking to do is find out the change in kinetic energy. So how can we find the change in kinetic energy? Because now we have to find the velocity at time 0 and velocity at time equals t. So that will give me the change in kinetic energy. So now let's focus on this. So velocity can be written as ds dt a root s. Okay. Now if we bring root s this side and move dt the other side, okay, and if we integrate both sides, let's say from 0 to time t. So let's say at time t, the displacement was 0, and let's say at time 0 the displacement was 0, and at time t the displacement is s. Then when we solve this, we get displacement time graph. Okay. Now if we integrate both sides, this becomes s to the power half by half. The limits are from 0 to s, and this becomes at. Again, the limits are from 0 to t. So we can write this as 2 root s is at. Okay. Now at time 0, then s is 0. At time t, we know s is a square t square by 4. Okay. Now if we substitute that back in the original equation, so we get velocity at time 0, displacement was 0, so this, and velocity at time t is a root s. So a root s will be at by 2, or we can write a squared t by 2. Okay. Now let's get back to the work energy theorem here. So what is the final kinetic energy? Half m vt square. What's the initial kinetic energy? Half m v0 square. So this is 0, and half m vt square is a to the power 4 t square by 4. So the answer is m a to the power 4 t square by 8. Okay. So this is the work done by all the forces.